Hello everyone, thank you for your patience. Our next talk is about OpenHarmony OS, a unified distributed operating system. Please welcome Lazar Stricevic.
How many of you knows about OpenHarmony? Have you ever heard about it? 1, 2, 3, 4. Okay, so for a lot of people it will be a new thing, right? Which I'm glad. Before we begin, I would like to say that although I work in Huawei, I'm in Dresden Research Center in Germany. I'm here as a private citizen, and everything I say is my own opinion, and the company has nothing to do with it. Okay, well, something needs to be said. This talk was based on the presentation I gave a few months ago at the University of Novi Sad for my colleagues there. I used to work there as well. About OpenHarmony, because they also did not know much about it. So I compiled some information. Just be aware that what I say here may be in some way out of date, because the events are really dynamic, it's developing really fast, and some things I may have gotten wrong, just to have this clear. Okay, so the answer to my question from the beginning, OpenHarmony is an open source operating system for smart devices like phones, like laptops, and even smaller devices like IoT devices. And what OpenHarmony does, it kind of treats them as it kind of unifies them. And it's a base for the Harmony OS, which is operating system developed by Huawei, and it's used in currently almost all of their devices right now. It's a project which is operated and based in Open Atom Foundation. For those of you who have not heard about Open Atom Foundation, it's a kind of Chinese equivalent of a Linux Foundation in the US. So it's kind of a foundation which holds open source projects there. How it came about? Huawei used to use Android for all their devices, and that was okay for a while. They had their own thing for a separate thing for IoT, and then came some political circumstances which kind of forced them or sort of nudged them to try to develop more stuff in-house. So to try to reduce dependency on other platforms which are proprietary. So basically, they started as an Android compatible platform, and they developed, and now they are no longer compatible with Android, at least not natively. So basically, it's an operating system which kind of fills the role of Android and plus some more stuff. So the Harmony OS started its role somewhere in 2018-19, and in 2020 it was donated to Open Atom Foundation to kind of foster open source ecosystem about it. So basically to do similar thing as Android did, to try to use that open source effect. And they licensed it pretty liberally as Apache license 2.0. So this was in China for out of China markets, mainly Europe. It was noted that there are some kind of discrepancies between the legal systems, between the demands, between the audience which is interested in it. So they kind of developed separate distribution called Oniro. Oniro means dream in Greek, if I remember correctly. This is under Eclipse Foundation, which is based in Brussels. So it's a European thing. It kind of integrates all these legal frameworks, mainly related to IP compliance, which enables it to be used worldwide. And it also has some ways to include other platforms, mainly mainly React Native, and also to add App Store, which is open source and free. So all the other stuff. So if someone here is interested in developing something for OpenHarmony, I think Oniro would be the distro of choice to use. So in short, OpenHarmony is developed as a open source thing. Then Huawei takes it, adds its own stuff. So I don't know why. Okay, so yeah, maybe it's and then it produces its own Harmony OS thing. Oniro is basically based on the same open source code. It's a superset of specifications, and it also it gets its own distro. So this is how it kind of legally works, right? So what's so different about OpenHarmony? So why is Huawei relying on it right now? As the name suggests, harmony means kind of a peace among many different things. Mainly in this case, many smart and IoT devices. So basically, OpenHarmony joins them together as one super device. How it does it? Well, it uses various technologies like distributed software bus, DSoft bus, which connects the devices. Then data is distributed and managed between them. They have scheduler, which is also distributed. So basically you can run one process from your computer on another device. And the peripherals are also virtual. So basically you can use your TV as a display device on your on your phone or whatever. you could have done it also, but you have to. You could have done it on Android before, but you will have to connect and be involved in this these connection details. With DSoft bus, it should be seamlessly, right? It should be integrated seamlessly. So how does it do it? Well, here's a short video how this, what's the use case for this? Can be,
小易，小易，我想看汪汪队。
我在平板和智慧屏上都找到了可以播放的视频，选择第几个？
在智慧屏播放第一个。
小猫咪困在玩具船上，正往外海飘去了。
好了，我们要出去了。
不要不要，我要看电视。
小易，小易，在手机上继续播放。
So what happened here? So basically, we had 4 different devices, like a smart speaker, tablet, TV, and mobile phone. And little girl wanted to see a Paw Patrol cartoon on her tablet, but switched the screen on the TV, and then they needed to go, and basically it was just transferred to her mom's phone, and it was all basically one device. You just switch between them seamlessly, right? So how does it all work? This is architecture. We'll not go into the details, but the main thing is basically you have different layers, starting from bottom, like from the kernel layer, then the system service, which kind of does all the distribution, application framework layer. Framework layer and then the application. So basically, and each layer is kind of flexible, right? So, for example, for large devices, you would need powerful kernel, which would be Linux. For some smaller devices where you have not so much memory, you could use some real-time kernel like LightOS, and there are several other kernels which are supported. These are open sourced. So basically, OpenHarmony is currently using this one. Maybe I hope that there will be some more kernels available for this in future. Also, devices are virtualized through the hardware driver foundation, or HDF, which is a layer between kernel and the drivers. So basically, kernel has a way of dealing with all devices seamlessly. Okay, so how does it? So basically, all these are modules, right? And you can compile any number of modules dependent on the type of the work that you need to be done, right? So there are predefined three kind of sets of modules, like a standard system for the laptops and mobile phones. These are for big CPU, which has at least 128 megabytes of RAM and more. Usually, so this runs with Linux and complete app framework, which supports interaction, so screens, input devices, and everything, right? Small system is a kind of system which has a smaller CPU, less RAM. But it's still a device with MMU, with memory management unit. It has still has higher security capabilities, but it doesn't have all the bells and whistles from the standard system. And finally, we have a mini system, which is based on microcontrollers, which has 128, which are 128 kilobytes of RAM and higher. So basically, this is the current requirement. It may be possible to write with even less. But yeah, so basically, these are devices which don't have graphical interface, which don't have support for wide range of components, which usually devices which serve only one purpose or two, right? So like kind of sensors or refrigerators or microwaves and so on. So with these three standard systems, with these three classes of sets of modules, usually most of the devices are covered. So what is with OpenHarmony hardware? So basically. Currently, OpenHarmony is tested with its CI on these three types of sizes of the system. So mini system is tested on V200Z-R, which is some kind of IoT board with Wi-Fi and audio capabilities. Small system is high spark towers, is some kind of camera system with standard system is Runhe High Hope Dayu or 200 board, which is Rockchip actually based. The first one is microcontroller and 33 times with 2 cores. Small system has Cortex A7, which is 32-bit ARM, and standard system is 4 times A55, which is 64-bit ARM. On the slide, there is a picture of Dayu board, which we normally use for our testing. It can be purchased in China normally, and then now, since recently, you can buy it even on Amazon in Germany, for example. Just didn't say that for these 3 types of systems, you can download images which are built daily. How about the apps on the OpenHarmony? Well, they can be installed manually or through App Store. There's a really big parallel with Android because it was developed from Android. So on Android you have APK. Here you have Harmony ability packages, which is HAP. You have Google Play Store. Here we have Oniro App Store for European market. All right. They use ArcUI framework normally, and they are, but Android's apps, for example, are supported by third-party container apps. Also, on laptops which run Harmony OS, you can run Windows apps through third-party container apps. So basically, you're more or less covered with this. Of course, it's all fairly new, so you might expect some hiccups here and there. But yeah, it's a friend of mine usually recently bought a Huawei phone. He uses it here in Novi Sad, and now he even got the new MateBook laptop. So we'll see how will he handle it here in Novi Sad, right? Okay, so how do these apps work? So there is basically two main paradigms for OpenHarmony apps. They can be run they can be developed as a regular app, or they can be developed as a widget. So basically, for regular apps, there is a new language which is developed specially, which was developed by Huawei to support this distribution of apps and data. It was based on TypeScript. First it was called ExtenderScript or ETS, and now it's called ArcTS because it uses ArcUI framework. For smaller widgets, you can use normal JavaScript or CSS. So currently there are numerous improvements on rendering engine and platform layer. So basically, these things I didn't want to provide too much details here, because it would be out of date by the time I got here. So what about development tools? On Android, you have Android Studio. Here you have Deveco Studio, development ecosystem studio, which is based on the IntelliJ, same as Android Studio. So other types of tools include also equivalents of Android tools like HDC, Huawei device connection. It's basically a Huawei version of or HarmonyOS version of ADB, right? ADB on Android is, and also all of these tools are available for download freely. So basically, you can get them and to start developing. And here you can see how does it work to develop with Deveco Studio. Basically, you have if you develop for a phone, you have an emulator where you can try your apps before installing it to the phone. Similar thing as on Android. Does it run on anything else? Well, it does. It does run on anything else. Here, we have it running on Raspberry Pi. So, and actually, I brought Raspberry Pi with me, and we'll see how it runs. We tried to boot it before. I'm not sure if it was successful. We'll just see. Okay, yeah, well, it booted up. The time is wrong because, it's 1st of January 1970, yeah, but everything else seems to work. Yeah. So yeah, this is a basic installation of OpenHarmony on Raspberry Pi. There are, for example, yeah. So this is OpenHarmony 5, which is slightly behind. Now there is so current version is 5.1, and the beta version is version 6, which is due to be released soon. Yeah, and yeah, that's. I mean, I have hope to do. I was hoping to do some kind of connection between the computer and the Raspberry Pi, but that would require configuration of networks, and we just didn't have time to do it before the presentation. Anyway, so basically, this image you can just download, or you can compile it from the source code. Yeah, and yeah, so not much of a demo, but yeah, here it is, running on Raspberry Pi. This one is 4B. 4B. This is what we have. What's currently, and this is a Oniro distribution running on it. So European version, so to say. Yeah. Okay. We can go back to the presentation. Okay. So yeah. So you saw it running, and we are back to so we have I think 10 minutes more. So I will conclude. We heard about OpenHarmony. So it is an open system which you can use on your own. You can modify it, you can use it freely to whatever you like. Why would you use it and not Android? Well, it's another alternative, right? It has its own ecosystem, has its own community, mainly in China. In China, there are many student developer clubs on universities. Here, not so much. Who knows? Maybe that changes. And Oniro project is basically adaptation of OpenHarmony for European market. And yeah, so if you're interested, go ahead and use it. Right? Here are some interesting links in case you are interested. I will leave the presentation so you could pick it up online, hopefully. So mainly about the OpenHarmony project itself, repository. So basically, you see there is the OpenHarmony repository is based on giti.com, which is a kind of Chinese GitHub, right? You have also SDK and all the development stuff there. Also, on-air projects has their own stuff, and they are based on GitHub. So with that, I would conclude my presentation, and I will take questions now. Thank you.
So if there is a set of these devices with Harmony OS, should there be a device that's like a hub or a controller that we can control other devices through that one central device, or it's completely distributed?
So basically, normally you would have one standard device to be joined with these small or tiny devices. Yeah. So basically, two microcontrollers. I mean, there's not much they can do.
Yes.
They can do. So there should be someone who needs a service from
okay.
them, yes.
And my other question would be, if there is a third device, like an air conditioner that supports Google Matter protocol, is there some integration for Matter Bridge or something like that?
So far, not that I have heard of, but it's certainly possible to do it, right? So, I mean, there is no technical obstacles. What Huawei also has, which I did not mention here in this presentation, it has their own sets of technologies for like a replacement for Bluetooth, has their own thing called Nearlink, has their own media connector and stuff like that. So basically, if there's some kind of proprietary thing, then this might be an obstacle to connect with some. But for this, I think this is open, right?
It's open
Yes,
protocol. Yes.
So basically, someone can implement it. Maybe you.
yeah. Okay. Thank you.
Cheers. Hi. So as you showed in your presentation, it looked like from a developer standpoint, it was really close to Android. My question is the following. Is from a threat model perspective, the same classes that are on Android apps, is it still here present on OpenHarmony, like starting an intent from a different app? Is that possible?
Sorry, starting what?
Starting an intent from an app you develop on OpenHarmony, is that also feasible as an attack surface on OpenHarmony?
I mean, I believe I'm not there to claim that I know the answer for this.
Okay.
But I would say that most of the stuff which applies to Android would apply here.
Okay.
So there are some more security features here. For example, here all the apps needs to be signed, and you cannot run anything any code that's not signed by default, right?
Okay.
So maybe attack surfaces are smaller in that regard, but I'm not sure if answer to your question is yes.
Not related. To a degree, yes. To a degree, no. It's okay. Go.
So it looks to me it's essentially yet another Android with yet another protocol layer. For reasons they made it okay. But question one, what part of that is open source and will be open source of the complete stack up until the UI and what's called Harmony? And next, that USP you showed, like that seamless communication from device to device, including data transfer from some local TV at home, moving outside of the home, which is not a simple task in the end. How is that realized?
Sorry?
How is that done? How does it work?
How does it work? Actually, the first part of the question, everything I showed here is open source. So basically, you can download everything from the source here and compile it for yourself, or modify it, or do whatever you want. So basically, this is open source. There are some stuff which is the devices on the video use stuff like drivers and some technology which is proprietary. So, there is no reason for this thing not to work with the open source with proper development glue, so to say. The things about connecting devices, how does it work? It uses this technology which I mentioned before, which is called, this distributed software bus. Basically, there is a scheduler within this, which kind of can schedule a process and transfer it on another device. So what you have to do is to pair devices once, and then they recognize each other, and you can just and then they collaborate, and using this software bus, they can transfer processes and share data between themselves.
Mm-hmm. Transfer as in code snippets getting transferred from A to B.
Yes. I mean, there are also kind of abilities which are related to each device. What each device can do. So basically, if the code meets these abilities, it can be transferred, right? So you cannot run video on a device which doesn't have display, for example, or is not powerful enough to run a video. So basically, there are those kind of requirements. But for user side, like if you're just a user, if not a developer, then you should not worry about it in theory, right?
Okay, thanks.
In practice, yeah, these things might happen.
Thank you. Sadly, we don't have any more time for questions. Everyone, please, another applause for Lazar.